Here we will discuss about representation of monosaccharides. See here in the left hand side you have the structure of glucose actually. See how do you represent monosaccharide? Glucose is an aldohexose. What's the meaning? It contains hexose means 6 carbon, aldohexose means aldehyde as a functional group. See, so there are 6 carbon, they are numbered as 1, 2, 3, 4, 5, 6. This is numbered as 1 because this is the functional group, aldehyde. Now, what they are doing is, while representing, see, this representation is actually called a Fischer representation. Fischer, F-I-S-H-E-R, Fischer representation, in which the most oxidized carbon. See here you have the OH carbon, all these are OH carbon and this is aldehyde. And among this OH carbon and the aldehyde, aldehyde is the most oxidized one. The most oxidized carbon must be put at the top, it must present at the top. Then the further carbons are represented one after another below. Now here what they are doing is, this is a carbon and this one is actually a chiral carbon. How do you say this is a chiral carbon? Here you have an OH group, here there is an H. So here the 4 different groups are attached. One is an aldehyde, this is an OH, this is H, and here all these groups are attached. So definitely this is a chiral carbon. So here 2, 3, 4, 5 are chiral centers. So what they are doing is, chiral carbons are represented. Here you can see. So this carbon also is a chiral carbon because OH, CHO, H, CH2OH, different groups are attached. The chiral carbon is represented as a cross. You can see in the further figures, the chiral carbon will be represented as a cross, or you can say the chiral carbon is at the intercept of the horizontal and the vertical line. I may show you one such a representation of, I'll show you in the upcoming videos, the classes, how they are representing a chiral carbon. Okay, so we'll come back to our discussion. So these are chiral carbons. Now the further group OH and H are represented in a horizontal manner. OH and H. So this is the way of monosaccharides are represented, and the CH2OH will be at the bottom. Now here you have a molecule called glyceraldehyde. What is glyceraldehyde? It was an aldotriose. There are 3 carbons. Only 3 carbons are there. Now on this glyceraldehyde, see you have the OH group on the chiral carbon, on the chiral center. The OH group is present on the right side. Then it is called capital D glyceraldehyde. Look on this object here. The OH group is present on the left side, so it is called capital L glyceraldehyde. And this way of representing a carbohydrate is known as DL notation or DL designation. So this is simply based on how the OH group is attached on the chiral center. If it is on the right side, it is capital D glyceraldehyde. If it is on the left side, it is capital L glyceraldehyde. Remember, this capital D and L have no relation with what is so called dextro and levo. Dextro and levo are actually optical activity, while this capital D and capital L simply represent the right hand representation or right hand alignment and left hand alignment of the OH group. That's all. There is no optical activity related with this capital D and capital L notation that you have to remember. The dextro and levo are usually represented by small letter D and small letter L or plus or minus sign. That's the way how they are represented. Okay, we'll continue the